All right, for problem 5, we're going to see a new type of indeterminate form. I apologize, this is a retake on this video. My pen started doing weird things on the previous problem. So what we've got here, if we try to plug in values into this limit, we can see that the square root of x as x comes from the right is going to go to 0. But ln of x, as we check the limit from the right, is going to go to negative infinity. So what we actually have here is 0 times infinity. So this is one of the special indeterminate forms that we showed you, right, in the intro video. And so we're going to have to do some work to get it in L'Hopital form. So we said you can try moving an expression into the denominator, but we want to move the simpler of the two things into the denominator. So if I rewrite this as in terms of fractional exponents, I can rewrite the limit as x goes to 0 from the right as ln of x over 1 over the square root of x. I also could have written that as x to the negative 1/2, right, moving it in. But I think it makes a little bit easier sense to visualize the L'Hopital form if we do it this way. So we already see that in the numerator, right, this limit as ln goes to negative 1/2 is still negative infinity, because that's where this came from in the first part. But now what I have is a 1 over 0 situation in the denominator. So I'm ignoring the numerator for a second. If you're having trouble visualizing why these two things are equivalent, well, if you divide by a fraction, you multiply times the reciprocal, right? And that puts that right back in the numerator. So these are, in fact, equivalent expressions. So 1 over 0, if you're coming from the right, is going to give you your second infinity. So, and it's going to be positive because the square root is always positive. So it's just really, really tiny positive things. So now we're in a L'Hopital situation. So if I take the derivative of the numerator, the derivative of the numerator is 1 over x. Now I'm going to take the derivative of the denominator, and it's 1 over 2 root x. Oops. It's actually going to be negative 1 over 2 x to the 3/2, right? So if that were x to the negative 1/2, I would get negative 1/2 x to the negative 3/2, and then when you write it in the denominator, it makes it positive 3/2. So now I'm going to divide these fractions, because I still can't really tell if this will simplify. So if I divide the first fraction by the second fraction, I get 1 over x times the reciprocal of the one on the bottom, so that's negative, right, 2 times x to the 3/2 over 1. Now I see that this will simplify, because I can cancel an x out of each of these, and now I have the limit as x goes to 0 from the right of negative 2 times the square root of x. Now, if I try to evaluate this at 0, I just get negative 2 times 0, which is 0. So we could have left it as x to the negative 1/2 here. That would have made some of the calculus maybe a little bit easier to do in terms of the derivative, but it might have made it harder to simplify. And also you want to make sure, I think it's a little bit easier to visualize the infinity happening here if we actually write it, so you can see it's a 0 in the denominator of that guy. The next one is another type of indeterminate form. And so in the same way, we were getting 0 for doing 1 over x, right? If we do this from the right, we're going to get infinity. Sine of x, as we go to 0, is also going to be 1 over 0. So we're actually getting an infinity minus infinity situation here. So this was another type of indeterminate form that we showed you on the front, right? The indeterminate difference. So we don't actually know if this is going to, you can't ever assume this is 0, right? Because one of these infinities might be bigger than the other. So what we can do is we can try to get a common denominator and see if that puts us in L'Hopital's form. So the common denominator here is going to be x times sine of x. So I'm going to take the first term and I'm going to multiply this by sine x over sine x. So I'm going to get sine of x in the numerator. Then the second fraction I'm going to multiply by x over x. So I'm just going to get x, and then this is all over x sine of x. So now if I try to evaluate the limit, I see that I'm going to get 0 minus 0 in the numerator, which is 0, and 0 times 0 in the denominator. So now we're in the appropriate L'Hopital form. We can actually apply the rule. So the limit, as x goes to 0 from the right, I'm going to take the derivative of the numerator, so that's cosine x minus 1, over, and I have to do a product rule here. So the derivative of the first term is 1 times the sine of x, plus the first term times the derivative of the second term. So this looks like it got worse, but let's see what happens if we try to evaluate it now. Well, cosine of 0 is 1, so 1 minus 1 is 0. This is 0 plus 0. So we're still in 0 over 0 territory. So now let's apply L'Hopital again. So now when I take the derivative of the numerator, I get negative sine x. And when I take the derivative of the denominator, sine of x becomes cosine x, but I have to apply the product rule for this piece. So the derivative of the first times the second just gives me cosine x, plus the first term times the derivative of cosine is negative sine x. So now I'm going to clean this up just a bit. The numerator is just negative sine x, but in the denominator I have a cosine x plus a cosine x. So that's 2 cosine x minus x sine x. So now let's check what happens if we plug in 0 now. We get 0 in the numerator. We get 2 times 1, which is 2, minus 0. So we end up getting 0 over 2. So the limit of this is 0.